So how do we find our axis of symmetry? Opposite b over 2a, negative b over 2a, however we want to word it. So our x is, how do we put it together? Negative 4 over 2 times 1. So where is our axis of symmetry at x equals? What is negative 4 divided by 2? Negative 2. So let's find our vertex. We're going to do that by substituting this piece in. So we're going to have our negative 2 squared plus 4 times negative 2 minus 12. So what do we get as the y value for our vertex?
Negative 6.
A couple of different ones. So let's the negative 2 squared, that's going to be 4 minus 8 minus 12. Yeah, we're going to wind up at negative 16. So yeah, that doesn't work.
Yeah, all the points that I got are not even on the graph.
Yeah, it's not going to show up on the graph. It would have to be out 5 or 6 more steps. So we're not going to graph it. We're just going to find that vertex. We're just going to call that good. So this is going to equal our negative 16. So our vertex, the point, is at the point negative 2, negative 16. It's just off our graph. I think if I got to 0, I think we got to negative 1. We could maybe get there. Because it should be right side up. Some of those, I didn't have a problem. Things happen. It's not pleasant, but it does a thing. Okay, so questions on the finding of the vertex part of this? Yeah, we'd have to get out to things like positive 2 and negative 6 to be able to actually get it on the graph. So we go pretty far away from our points. I will probably change that for the next test. So what we're going to do today is we're going to use our graphic stuff to solve. So we're going to start finding solutions for quadratic functions. So when we are solving any of these graphs that are not lines, we have a lot of names for our solutions. In fact, there are 4 names for the solution. They all mean the same thing. It's just looking at them through a slightly different lens. So we're going to find solutions. That's the first one. A lot of times the instructions will just say solve. So the first thing we can call them is solutions. We will also call them roots, which comes from the basis that it's got powers, and to undo a power we use square roots. We will also call them zeros because the solution happens where our f of x equals 0. That's why it's called a 0, and that's where we look for our solution, is when it equals 0. And our last thing we can call it is actually the one that makes it easiest when we're looking at a graph. Our solutions are not going to happen with a highlighter. There we go. Our x-intercepts. So when we're solving with graphs, we're looking for where it crosses the x-axis. also known as when y equals 0, which is also when f of x equals 0. So those four words we use interchangeably. Our solutions, our roots, our zeros, our x-intercepts. And honestly, for the first few weeks, it's going to become really annoying because I tend to use all four of them every time. Just so you remember, it's our solutions, our roots, our zeros, our x-intercepts. That's what we're looking for. And so we're going to do that today by graphing. It's not the most efficient way to solve a quadratic equation, but honestly, at this point, it's kind of the only one we got. Bless you. We'll work through some more options a little later on. But what we're going to do is we're going to take those graphs we've been making, and then after we make the graph, we're going to look at it. And we're going to find our solutions. Okay. So, that was not what I meant to do. So what we're going to do is we are going to solve things by graphing, which means you're going to need some graphs. I have graphs. So our first one that we're going to graph, I'm going to put it up here, is this guy. It looks weird. I will trade you. Thank you. All right. So we have an equation up here that looks weird. It's got things on both sides of the equal sign. And it's kind of icky. So I want us to think about what we wrote next to the word zeros on the previous page. We need this thing to equal what before we can solve it? We need it to equal what? 0. So when we have weird looking ones, we're going to make it equal 0. And I would really rather not deal with a minus x squared, so I'm going to take everything and put it over there. So I want to add my x squared to this side, and I'm going to subtract 10 from this side. Or from both sides. So the first thing we need to do whenever we're working with quadratics is set it equal to 0. Or get it equal to 0 if that is better for your brain. So what I'm going to do is I'm going to add x squared to both sides to get this to move over here. And I'm going to subtract 10 from both sides because I'd really like this to equal 0. If I subtract 10 and add x squared, the left-hand side turns into a 0. And my right-hand side is going to be x squared plus my 4x plus 14 minus 10 gives me 4. I cannot combine x squared and 4x because they're different. They're related, but they're different. I always think of x's and x squareds like apples and apple pie. Yes, they are related, but do not take a whole raw apple and try and put it into the apple pie and call it another pie. There's a whole lot of process involved before we get there. It's like they're related. They're very similar. They have similar flavor profiles. One is involved in the other, but they're not the exact same thing. When we start adding other exponents, then we get apples, apple pies, and apple trees.
One has more sugar than the others.
It does. It also has a lot more process involved in making it. Oh, snap, like a square. And then if we start tossing in like cubes, then we have apple trees, which are not the same thing, but again, related.
Technically, if I remember correctly, you can't plant apple trees. You have to like.
It's because apple trees cannot pollinate themselves. You have to have apple trees in pairs because they have to have parts from different trees. They can't self-pollinate. Trees are weird.
Yeah.
We're just gonna go with trees are weird and apples are picky. All right, so we have to get it to equal 0 before I can do anything else with what we're doing. But from here, it's exactly what we did graphing it 2 days ago. So we're gonna find our axis of symmetry. We're gonna find some points. We're gonna graph it. So my first step is our axis of symmetry, just like we did in the bell work. We're gonna have our x equals our opposite of b. So we're gonna have our negative 4 over 2 times a, 2 times 1. So in fact, we wind up with the exact same axis of symmetry as we had in the one in the bell work, where our x equals negative 2. What that helps us with is in our table, when we're looking to plot stuff up, we put our axis of symmetry right in the middle, our negative 2. That lets us know that that's the center, and our pieces on either side should match as long as I count outwards by the same unit, or outwards usually by 1. So we're going to use x's of negative 1 and 0, and negative 3 and negative 4, because we need to go onto both sides of the equation. So what we're going to do is we're going to type in our equations, add our values to find our points. So substituting in our values, what do we get when we start to fill in these points?
0 and negative 4 and 4.
Mm-hmm.
Negative 1 and negative 3 and 1. Negative 4, yeah, 1. And then negative 2 is 0.
I did negative 2. Yeah, that's what it is.
Yeah.
4, 1, 0, 1, 4.
Yep.
I was just doing it from the outside in.
Yep, you were, either way is fine. However you do it and fill in your table is fine. When I'm looking at these filled in tables, I can't tell what order we wrote them in. So whatever way works for you best, works for your brain best. All the words.
Formula in the original formula.
Typing them into this guy right here.
Yeah, that guy right there. When it's equal, that's what you type in.
So we're just typing in the x squared plus 4x plus 4. And I put in my 0 squared plus 4 times 0 plus 4. Or we could remember that in our standard form, that c, that's our y-intercept. Since we knew we have symmetrical data, because I knew I put my vertex in the middle, we know that these guys match. And we know that these guys match. So we really only have to type those in. Let me grab the calculator then. Boop, boop, boop. I got to close this. Sorry, I forgot my calculator. What's up? Yeah, we're going to graph it. We're just working on, there was a question on how we got the values.
Of course, there's an app.
This is the yellow calculator with all the exact same buttons in the exact same places. It's just a little square up on the screen. So when we are substituting in those values, so let's say we did that negative 1. I'm going to take I'm going to open the parentheses, and we're going to put our negative 1 squared plus 4 times negative 1 plus 4. And you can just type it in, except I didn't use negative 1. I put a negative 4. Boop. There we go. Fixing. There we go. Now I type in all the right things. So this is how we type it in. This is how we can put it in the calculator. Then you just hit enter, and it spits out our 1, which is exactly what we have on our table here. For that -1, we have a 1. Okay, so we're just taking these x values that we chose that were on either side of our vertex and typing them into the equation. Because then what we're going to do is we're going to graph that. So I've got my points at 0, 4, -1, 1, -2, 0, -3, 1, and -4, 4. So our graph is going to look something like this. Then what we need to do, because we have one more step today, it's not just graph, is we're looking for our solutions. Remember, our solutions, our roots, our zeros, our x-intercepts. Where do we have an x-intercept on this one? -2. Where it hits or crosses our x-axis. That is our solution. So our solution, or root, or zero, or x-intercept, happens when x equals -2. And I'm okay if you write it like that. It has to have all those pieces. Our solution's not -2. It's when x equals -2. Or put it as a point, -2, 0. So this is how we're going to write our solutions. So we're looking for those x-intercepts, those roots, those solutions, those zeros. Questions on this one? Ew, the rest of these are both kind of gross, but that's okay. We'll do this one next. I'm going to kind of bounce around because I don't really like either of them, but you know what? It happens. All right. So let's do this one. I've got my f of x equals -x squared plus 3x plus 7. And we're asked to find a solution. We're asked to solve. So our first step is to find our axis of symmetry. Because we want to graph this. So we're going to do our axis of symmetry. Which is going to happen, it gives us our x. How do we set this up? -3.
And since it's technically a 1 in front of the x, it would just turn a -1 in front of the x, it would just turn the 2 into negative.
Yes. So we've got our -3 over 2 times -1. Opposite of b over 2 times a. So what is our axis of symmetry?
1.5.
-3 over -2. So our negatives cancel out then. So 3/2, which is fine. Or we can put that as a decimal. And it's about 1.5, or it's 1.5, not about, it is 1.5. So that tells me my vertex isn't going to be right on a line. So we need to be careful and make sure we pick things carefully in our table. Because my middle is right at 1.5.
So we could probably do 1,
I was going to say, what's something smaller than 1.5? 1. What's something bigger than 1.5 by the same amount? 2. So I went down by 1/2 and up by 1/2. So it doesn't matter how big our steps are. I just need to go to either side the same amount. Because that'll let us still use the fact that it's symmetrical to do so. So I'm going to go out again just so we can have more information here. So again, smaller than 1 Well, now I can go back to my whole steps. I don't have to take the same size step the whole way in the table. This is 100% a valid way to build a table. It's not as intuitive to us sometimes because we have that decimal in the middle, but that can happen sometimes. Quadratics are weird. So now what we need to do is we need to find our values for our table. We have one up here that's got a shortcut. Which one do we not need to type into a calculator? 0. So what is our y going to be for 7 or for 0? What's our y-intercept?
7.
7. This guy always goes with the x of 0 when we're in that standard form.
So that means 3 is.
So that means 3 is also going to have a value at 7. Because the way we set up our table, this guy's in the middle, and we took even steps outwards. We matched. So we only really have 2 more pieces to substitute into the equation. So we're going to do our 1 and our 1.5. Or you could do 2. Doesn't matter. And I'll do it in the calculator just so we can see it. So we're going to have our negative, and I'm going to do the 1. 1 squared plus 3 times 1 plus 7. I'm just typing in the whole equation exactly as it looks. And we get 9. So for 1, we have a value of 9, which means also for 2, we have a value of 9, because we are symmetrical across right here. And our last piece, we're going to do the same equation, but we're just going to do it with our 1.5 or with 3 halves. You can do it either way. But I'm just taking our equation, so we're going to do our 1.5 squared plus 3 times 1.5 plus 7. And we get 9.25. So our vertex is super gross and decimally. So plot up your points. So I've got my 0, 7. I've got my 1, 9. I've got 2, 9. And I've got 1.5, 9.25, which is kind of right there-ish. They're super close together, but it gets the vibe. And then we've got 3, 7. So what we have here is an unpleasant parabola that goes like this. Ooh. And it's going to look kind of like that. So it's icky and gross.
It's a baby.
Huh?
It's a baby.
It's a baby. Icky and gross. So where do we have solutions? That's our big question. We don't really know. So pick 2 values on either side of it. So it's going to be somewhere between, probably, what 2 values? Yeah, somewhere between -2. Mine's right between -2 and -3. Again, however yours shifted, yours might be between -3 and -4. Honestly, we're doing these graphs by hand. We're not super specific with it. So we're going to have one between -2 2 and negative 3.
Mine
That's-
is right on negative.
Okay. And say yours is a negative 3.
Uh,
We're graphing by hand. If we were graphing on like graphing calculators, we could be exact and specific, but it's not super close. Mine is right smack between. Where else do we have a solution?
Between 4, 5,
Mm-hmm.
4 and 9, it's 6 and 7.
Yep. We're graphing by hand. Again, these are estimates. If we want graphing perfection, we use a calculator or Desmos. We don't have that, so we're using the graph we have and getting the answer we can. We will figure out ways to get better, accurate answers later this chapter. Because right now, we're doing what we can with what we can. So our other solution is going to be between, mine is between 4 and 5. If you wind up right on a point, go with that. If you wind up between points, just tell me what you're between. That's part of the reason we have to have the picture there so that I can see if it matches what you did, not if you match what's on the calculator on the computer or what the AI assistant did for you. All right, we're going to do one more. It has a grosser start but a cleaner answer. Okay, so I just shifted them around because this one has a really gross answer, but it's a cleaner start. So our last one we're going to do today is kind of a story problem.
Yeah.
Yeah, I know.
So we don't have a C in this one, I'm guessing?
That is not what that means.
It's confusing.
I know. We've got the sum of two numbers is 14, and the product of those numbers is 45. So let's use x and y just because that's going to make our lives easier since we're looking at graphs. So how do I say that the sum of two numbers is 14? Yeah, I could say x plus y equals 14. I don't know why I drew the 4 first, but I did. Like, that's a thing we can say. How do I say that the product of the numbers, what does that mean?
X times Y.
X times y.
And if you know the X, if I can answer, it's 9 and 5.
Yeah, I know, but we're going to do it the right way.
I know. It's annoying when
I know, but what if it was like 225?
Huh?
What if it was a product that was 225? I gave us an easier one to spot. All right, so what we can do with this is when we have problems like this, which is actually a system of equations, what? Oh my gosh. I want to take these two equations and smash them together. What could we do? Think systems of equations. We just had chapter test over this. Subtract x on the top one so that we get a y equals, because then we can use substitution. I can make this top one be y equals 14 minus x. That's a thing we can do. Subtracting x from both sides. Then what I'm going to do is I'm going to take that y equals and I'm going to substitute it into my other equation. So we're going to have our 45 equals x times 14 minus x, or minus x plus 14, either way. So we're going to substitute it in. So when we have these kinds of story problems, we're going to look for a system we can use substitution on. Because what we're going to do here is now I'm going to distribute the x across this piece here, which is going to give me 45 equals x times 14, which is 14x. X times minus x gives me minus x squared. And then we're into very similar to what we had at the very first question, where I want this to equal 0 before I can try and find my solutions, so I'm going to subtract the 45 from both sides. And I'm going to scooch this around so it's in my standard form. Remembering that our standard form, that's when we have our ax squared plus bx plus c. I'd like it to be in that order. So I'm going to scooch some things around so that we're going to have 0 equals my minus x squared, my positive 14x minus 45. So I told you I had a grosser setup. But we have a better answer here. I promise. So where is our axis of symmetry? That's going to be the first thing we want to solve this by graphing. Where are we going to put our middle of our parabola? Negative 14 over negative 2, also known as, what is negative 14 divided by negative 2? 7. So that 7 goes in the middle of our axis. I want some bigger and some smaller. So bigger than 7, we can use 8 and 9. Smaller, we can use 6 and 5. To find our y values for this quadratic, we are going to substitute those x values in here to this guy. My minus x squared plus 14x minus 45. So we're going to have our minus 5 squared plus 14 times 5 minus 45. So when I type in 5, I get a 0. Which means I also have a 0 down at 9. Let me do the same thing for 6. Actually, I'm just going to take the shortcut version, and I'm just going to arrow my way back. 6. Boop. We get 3. Which means for 8, we're also going to have a 3. What do we get for our y? For 7, sorry.
4.
We get 4. So when we graph this, we get points at 5, 0, 6, 3, 7, 4, 8, 3, and 9, 0. So where are our solutions? Our solutions are our roots, our zeros, our x-intercepts. It's also when we have zeros for our y. So our solutions are when x equals 5 and when x equals 9. Or write them as points, 5, 0, and 9, 0. Okay? So that one's a really unpleasant setup, but the graph was better than the last one. Questions on that one? Okay. We've got about 5 minutes until announcements. And I've got the next homework for you.
Oh,
It has 4 graphs for you to make on it. And 4 additional graphs for you to do. So you're making 4 graphs. And it's the same 5 of the graphs we've done. Not as unpleasant as one here. You guys have the rest of the time to work on stuff, ask questions if you got them. If you've got questions on homework 1, if you've got questions on homework 1, do the same. Alright?